Hello, in this video I'm going to look at applications of the Arclength formula S equals theta R, where theta is a rotation in radians. And I'm calling this part one because in another video I looked at how did this formula arise, like what's behind it, why does it make sense, and why does it only make sense in radians. So we looked at that in another video. And I was mentioning then, how do you use this formula? Well, when the path of an object or person is curved, right, it's following a path around like a circle. So that's what we're going to look at, these. And then in another video, we'll look at the example for number 2, the second kind of application. All right, so let's take a look at our first example. So nautical miles are used by ships and airplanes. They are different from statute miles, where hopefully you might be more familiar with that. A mile is 5,280 feet. So a nautical mile is defined to be the arc length along the equator, right, intercepted by a central angle AOB of 1 minute. So essentially you have a rotation of 1 minute here. So that's 1 minute, right? And here's angle AOB, and this is your nautical mile. So what they're asking then is, if the radius, the equatorial radius, so that's this radius right here, if the radius at the equator is 3,963 miles, use the arc length formula to approximate the number of statute miles in a nautical mile and round to 2 decimals. All right, so we have, this makes sense to use S equals theta R. It's a curved path. And we want to, though we have the radius, we also have the angle. So normally you just plug in, except that theta must be in radians. So I'm going to go ahead and say, well, what is that? So if we look at, here we have 1 minute. I want to go ahead and change that to radians. So I would say there are 60 minutes in 1 degree. So now I'm in degrees because these will cancel out. And now I want to go to what's familiar to me, 180 degrees is pi radians, or you could say 360 and 2 pi. Either one is fine. So all of this, when I multiply that, right? So here's S, the arc length I'm looking for, times theta. All of this is theta, but now it'll be in radians because these will cancel out, the minutes will cancel out, the degrees will cancel out, and I'll be in pi radians. Well, pi is just a constant. I'll be in radians. So there's my angle, and then here's my radius, so theta R. So this is going to be 3,963 miles. That was given to us. So here's R. And now if I just multiply all this out, I'll get 1.1528 miles. They wanted us to round to 2 decimals, so it would be 1.15 statute miles is equivalent to 1 nautical mile. Okay. All right, let's take a look at the next example. So we have here Eratosthenes, way back when, 240 BC, was able to calculate the circumference of the earth, which I find amazing. These guys had nothing but sticks pretty much, and they managed to do all this. So he knew at Sienne, which is now called Aswan, during the summer solstice, the noon sun was reflected on the water in a deep well. All right, so what that means is there was no shadow in the well. The entire circle of water reflected back, so they knew that the sun was directly overhead. Because if there had been any bit of shadow, then the sun wasn't directly overhead. So they knew that. And then he reasoned that if the so this means the sun was shining straight down the well and must be directly overhead, and he imagined that going straight down into the center of the earth, so that would give him a central angle. So then he reasoned that the sun's rays entering the well were continued down to the earth, they would pass through its center, and then on the same day, at the same time, 5,000 stadia, which is just their measurement of distance, which you would convert that, and that would be not 496 miles, due north in Alexandria, the sun's rays crossed a vertical pole, so that's all they had is a pole, at an angle of 7 degrees and 12 minutes. Now, of course, the sun's rays, they're coming from so far away that pretty much they're like considered to be parallel over the surface of the earth. So what you have then is this pole right here. Let's see, do I have like black pen? Yeah. You have this pole right there, right? And then it's casting a shadow. You can measure this distance, right? The shadow is easy to measure, it's on the ground. And you know the height of the pole, so therefore you can figure out what this angle is. And this angle is 7 degrees and 12 minutes. But remember, you have two parallel lines. Let me show you this one and this one, right? With a transverse, and so alternate interior angles are the same. So if this angle is 7 degrees, 12 minutes, this one also is 7 degrees, 12 minutes. So now we have what we're looking for, the radius of the Earth, right? And we have this circle, and we know the arc length. We actually know this distance because it's the 5,000 stadia, or 496 miles. So we have S is 496 miles. We have theta, which we just have to convert into radians, and then times R, we'll be able to solve for R, right? So that's amazing. So let's go through that and show you how that works out. So first, I have to get my angle theta, which is 7 degrees and 12 minutes. I want it in radians. So first I'm going to convert the 12 minutes into degrees because I'm familiar with those kind of conversions. So really there's 60 minutes in 1 degree. So you're going to get 0.2 degrees. So basically theta right now is 7.2, right? 2 degrees. Now, I want to use the formula S equals theta R. I still am going to have to change that into radians, so I'm going to just multiply by 180 over pi to convert that to radians. So now in here I've got 496 miles, right? Equals, this is my angle theta, 7.2 degrees times pi over 180 degrees, right? That whole thing is theta. And then times R, what I'm looking for, the radius of the Earth. So now all I have to do to solve for R is basically multiply by 180 divided by pi, and also divided by 7.2 degrees. So if I just do that to both sides, right, I'll have 496 miles, and that's going to be divided by 7.2 degrees, but then multiplied by 180 degrees, and then here multiplied by pi. Right, that's what R will be. So notice what will happen, the degrees will cancel out and you'll be left with units of miles, and pi is just a constant, 3.14, blah, 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 blah. So if you do all this in your calculator, you're going to get that the radius is 3,947 miles, which they will probably round to 3,950 miles. All right. But that's amazing, isn't it? Just using a pole and knowing some, some trigonometry. So now let's just take a look at the circumference of the Earth. Now that we have the radius, we know that the circumference is 2 pi r, right? So the circumference of the Earth is 2 pi r, but we know r. It's right there. So we'll have C equals 2 pi times 3,950 miles. And we're going to get that it's about 24,800 miles. That's the circumference of the Earth. Isn't that amazing? So that's the second example. And our last example then is here. So we have a figure here that shows the chain drive of a bicycle. Okay. And we're asked how far will the bicycle move if the pedals are rotated through 180 degrees. Assume the radius of the bicycle wheel is 13.6 inches. Now what they don't have here in the picture is, of course, this is the pedal where your foot would be, and then your wheel would be somewhere in here, right? It would be like this. You have your wheel right here with your spokes coming out. And what they're saying is that radius is 13.6 inches. So they didn't draw that in there, but that's understood to be there. Okay. So how do we approach this? Well, first we got to realize that this chain that's surrounding both gears here is going over them the same distance around, because if it weren't, you'd have some of the chain bunching up. So even though this this is a bigger wheel or a bigger gear than this one. Basically, this one's, the bigger gear is turning more slowly, but the arc length, which is the amount of chain actually riding along the edge of these gears, the arc length is the same. Because like I said, otherwise it would bunch up and then fall off. So they have to be, you know, the chain has to be, let's say, eaten up, if you will, at the same amount around both of them. So what you know then is the arc length of the, shall we say, the wheel, the, let's say the, what do they want to know here? Bicycle wheel, yeah, of the wheel is the same as the arc length of the pedal gear. Okay, but remember, S is equal to theta r as long as theta is in radians. So I can say theta of the wheel times the radius of the wheel, right? Theta. So theta 1 r1 is equal to theta 2 r2, if you will. I'm just putting in what they actually represent. Is equal to theta of the pedal times the radius of the pedal, right, gear. All right, so now we can plug in what we know. They tell us that the pedal is going to be rotated through 180 degrees. Now, of course, 180 degrees is pi radians, and we want to use radians when we're using this, right? Always theta in radians. So we have for the pedal, we're told pi radians. We also know the radius here, it's 4.72 inches, so 4.72 inches. And now the radius of the wheel we know, that's 13.6 inches. So we're going to find out what rotation, through what rotation does the wheel go. But remember, once we know this little, what rotation this goes through, it's the same as rotation as the big wheel because they're attached to each other. And so they go at the same, they go the same revolutions. All right, so when you do this, you're going to get here that theta of the wheel is pi times 4.72 inches divided by 13.6 inches, right? Which is going to give you about 10.745 radians, okay? Now, so now we know what this goes through in terms of the revolution. We know the radius of this. So obviously we now know theta and r for the wheel. All we have to do is multiply them together to get s. So now let's go ahead and do that. Clean this up. Okay, so the arc length of the wheel is equal to theta of the wheel times the radius of the wheel. So we know, we just found that out, 10.745 radians, 10.745 radians, right? Times the radius of the wheel, which they tell us is 13.6 inches. And that's going to give us the arc length of the wheel. So if you multiply all that out, you're going to get 146.13 inches, which we'll just say is 146 inches, right? So that's how you know how far it went, 146 inches. All right, thanks so much for listening.